Good.
Back and appreciative.
So we are recording. Okay. Now, if the rest of you, I just made it available to Abby, but if the rest of you need a recording, I can make it available to everybody so that I'll just post it. Okay, so here we have, here you have one item, 1 unit. And then in here you have 10 units making up a long. And then you have here 10 by 10 making up a flat. And then here you have 10 by 10 by 10 making up a cube. So for base 10, this will be 10 to the 0 power. Remember, any number to the 0 power gives you 1. So this is 10 to the 0 power, okay? And then this one is 10 to the first power. Okay? So it's 10. And then here, notice that this is 10 long and 10 wide. So that is 10 to the second power. And then here it is 10 long, 10 wide, 10 long, 10 wide, 10 high. That is 10 to the third power. Okay, so that's base 10. Now, if we want to do the same thing and represent base 3 using manipulatives, this is what it will look like. We will use the same one. Let me actually put it up here so you can see better. So that would be a 1. Then this would be right? So this is 3 to the 0, and this is 3 to the first power. Now, what would this one look like? At this place, it will be
3 by 3.
3y, right? So 1, 3. Right, so that would be 3 to the second power. And then for, this is going to be that. And then, of course, that is going to be right. Come down here. Okay, that would be 3 to the third power. So you can see in any base, it's always going to be 1. And then to the left of that is going to be the base to the first power, because this is base 10, is 10 to the first power. This is base 10, so it's 10 to the second power. Here is going to be 3 to the second power. And then 3 to the third power, and then here 10 to the third power. That is base 3. So that should show you the pattern for constructing numerical place value for different base systems. So let's try and construct a place value for base 2. Base 2. So you'll do the same thing, but you'll do it for base 2. Why don't you take some time and do a drawing for the place value for base 2? Okay, so for base 2, that of course will be 2 to the 0. And then this is going to be just 2 to the 1, right? Then here we're going to have two to the second. And then out here, we're going to have you got that? That's how your base 2 should look. Questions? Okay, so let's go to your materials at the back of the book and look at Cuisenaire rods, Cuisenaire rods, Cuisenaire rods. That's the orange rod. Okay, so, oh, by the way, I taught this class twice and then I was trying to, they have other different types of Cuisenaire rods and I was kind of holding it up and students weren't getting it. So I had to invest in some of these. First of all, I had to invest in a magnetic board. All thanks to COVID-19. And then I had to invest in magnetic manipulatives. But I think it's going to add to being able to explain the concepts a lot better. These are called Cuisenaire rods, right? Why do you use them? I'm not going to tell you, but based on what we do tonight, you will get an idea as to why we use Cuisenaire rods. Okay, so we will look at page 92 of your workbook, page 92. Page 92, take a look at that. And Andrea, can you tell us what it says?
Use Cuisenaire rods to solve the following. That one, right?
Yes, Number one, if the orange.
If the orange rod equals 1 each rod, is what fractional part of the orange rod?
Right, so then here, which one is the orange? Gotta know your colors now.
The bigger.
The first one, right?
Yeah.
Orange?
Yes.
That's the orange. So if that's the orange, we want to know the red is what fraction of the orange. So here is the red. What fraction is this of the orange?
8.
Well, let's see.
Oh.
Notice that this white one is 1 unit, right? The red is 2 of the white. Agreed? The red is 2 white. The, what do you call this, a lime color? Call this more lime, right? How many units do you think this one is?
3.
3, 4, 5, 6, 7, 8, 9, 10. So this is 10 of what?
10 of
The orange is 10 of the
white.
Red.
white. Very good. So the orange is how many of the red?
Nine.
The red can go into the
5.
orange how many times?
5.
So,
5 times.
5 times. 5 times. So then, what fraction is the red of the orange?
1/5.
So, let me just write this here. Let's see. So we're going to write a red equal what fraction of the orange?
1/5.
So first of all, it's 2 over 10, right? Agreed? Which simplifies to 1 over 5. Any questions as to how we got a 2? Because the orange is 5 of the red, but the red is made up of 2 of these, and the orange is made up of 10 of those. So the fraction for the red is always going to be the smaller number over the whole. The whole is your orange. So it's 2/10, which is 1/5. So let's go to the next one. B, let's go with green. Green equal, why don't you write the number down? Green is what fraction of the orange? Come on, give it to me.
3
3
out of 10.
divided by 5.
3/10 or
10.
5? 3/10. Good. Can we simplify 3/10?
No.
Okay, so then let's go to C, yellow. Yellow. Yellow equals
5/10 equals 1/2.
5/10, which is equal 1/2. Now, let's say that you wanted to prove that. Right? Let's say you wanted to prove that. You would take your yellow. See that? Takes 2 yellow. Takes 2 yellow to give you the orange. Are you able to see this okay? Good, so it takes 2 yellow, so it is a half, right? It is a half. Okay, and then we go to the next one. Purple.
4/10.
Purple. And 4/10 could be simplified to what?
2/5.
2/5. Okay, great. So that is that. So now we're going to vary the whole a little bit. Now they're asking us if the purple rod is equal to 1 whole. So now we're looking at this purple rod right here. That is your whole now. We kind of vary in the whole. Look at the purple. Now, the purple is made up of how many white ones?
4.
4. Good. So based on that now, why don't you go through and do A, B, C, and D? Remember, the purple is equal to 1. That's your whole. The purple is your whole. Take some time and do A, B, C, and D. And you can use your manipulatives that you have there and actually kind of manipulate, kind of move them around and see how they fit.
Professor,
Yes.
for the ones that are in our book, they're like attached. Should we separate the colors?
Let's see.
Like the 10 and the 1 are together, the 9 and the 2 are together.
Let me take a look at mine here. I think I took mine out. Not
They're
sure.
perforated the long way, but they're not perforated
Oh yes.
horizontally.
Oh yes. You can actually separate them.
Okay.
You can separate them.
Just because they're not perforated, so I wanted to ask.
Right. Oh, they're not perforated? They should have been.
They're perforated this way, up and down, but they're not perforated sideways.
Oh, okay. So what do you have to do? Cut them out?
Yeah, I just didn't know if we were supposed to.
Yes, yes, you need to cut them out. Otherwise, you won't be able to manipulate them.
Okay.
Professor,
Uh-huh.
so you're saying that the purple one is 4 of the red?
No, the purple is 4 of the white.
Oh, I can't see the white. Sorry.
Oh, yeah. The purple is 2 of the red.
That makes more sense. Thank you.
Okay. Yeah, that's because the background, the board itself is white.
Okay.
Mhm. Okay, so we have, we're looking at the brown. Okay, so we are actually taking this and comparing it to the brown. So the question is, if the purple is 1, then the brown is equal to what?
2.
2. The brown is 2 of the purple. Agreed? You can see it clearly here. Look at that. It takes 2 purple to make 1 brown. So next, remember we're keeping the brown as our whole, then we go to the orange. Orange. Here is your orange. Okay. And then we're going to take this next to that. This next to that. So the brown is 2 of the purple and 1 red, but we have to put it in some kind of a fractional form. So what we will do then is that we will try to compare the red with the purple. right here. Here is your hole. You want to find out, look at that. It takes 2 red to make 1 purple. So then a red is what fraction of a purple?
Half.
A half. Very good, a half. So then, when we compare the orange to the purple, it's going to be 2 and what?
2.5.
2.5. Or how many of the reds? 5 reds, right? 2 reds will go here, 2 reds will go here, 1 go there, will give you 5. 2, 1, 2 and a half. Or you can say 1, yes, 1 over 2. Abby, you're not too sure about that?
No, I'm just taking it in, just
Taking it
looking,
in?
observing. Yep.
Right, so you understand the relationship here, right? That the red is a half of the purple, agreed?
Yes.
So you can see clearly here, we took up 2 holes and we're still not covering the length of the orange. Was it orange we're supposed to do?
That was brown.
What it says here?
No, orange, yeah.
Orange.
Yeah, orange. So orange is going to be 2 and how much?
Like
1/2.
5.
How much?
1/2.
2.5.
Hold on. Just 2, yeah, 2.5.
It's the fraction would be 10/4, which simplifies to 2.5.
Yes. Right. Well, right here we can see that the red is a half of that. Correct. Okay, so then we go to C, and we will do dark green. Dark green. So our dark green is this one here. And remember, we were saying that the whole is the purple. This is dark green. You can see the dark green is more than a whole. Actually, it's a whole plus a red.
One and a half.
1.5, you say. Agreed? Very good. Equal 1.5. And then we go D. We're now looking at the black. And we comparing the black with our whole being the purple. Clearly, it's more than that.
So 1 3/4.
But let's see. Which other one? You think it's this one here, right? Yeah. So this is 4 whites, and this is 3 whites. So it's 1 3/4. Can you see that? 1 3/4. Okay, just make sure you write it in your book. All right, so next we're gonna go, if the red rod is a half, which rod is 1? If the red is a half, so I'm gonna go with 1. if the red is equal to half, then 1 is, but let's see. Let's
0.25.
see.
Purple?
We're gonna just see if we can, nope, not that one. Yes, you're right, the purple. Then 1 equal purple. Next, if the red is equal 1/3. Then one is equal, so here is the red. If the red is 1/3, we've got to take 3 of those. And we need something that is going to be equivalent to 3 of those. So this one looks more like it. So do you agree with that is the dark green? Dark green? Yes, no?
Yes.
Dark green. Dark green. And then we go to 3. If the white is equal 1/5. If white equals 1/5, then the whole must be, here is the white. So we know that
Yellow?
that's 2, and that, yes, 2 here and 2 there, 4 and 1, 5. So yes, yellow. Yellow. Then 4. If the white rod is 1/4. If white equal 1/4, then which rod is 1 3/4? Then 1 3/4 equal. So let's start with the white. Here is the white is equal 1/4, which means the whole, we gotta find something that is 4 times that size. What is that gonna be? Not that.
Purple.
Purple, right? So then this is the whole, right? If the white is 1/4, then the whole is really the purple we're talking about. So we need something now that is 1 3/4 the purple.
Black.
So what would
Black.
that be?
Black.
Black, let's see. And 3, let's see. Yes, this is a 3. Yes, 1 3/4. So then 1 3/4 equal the black. So let's go to number 5. If the red is 1/2, just move these around. If red equals 1/2, then which rod is 1 1/2?
Dark green.
Then 1 1/2 equals, well, let's see. Here is your red. That's 1/2, so then your whole will have to be what?
Purple.
Purple? Yes, so then that's your whole, that's a purple. So you want Oh,
Dark
you
green.
want 1.5, so that should be what? That should be anything that's this length, right? Anything that's that length. So let's compare. Take this and put it next to that. It looked like it's the dark green, agreed? Dark green. So then that would be dark green. And then we go to number 6. If the red rod is 1/3, which rod is 1 2/3? 6. If red equals 1/3, then 1 2/3 equals, so here we come with the red, 3 of the red. So then the whole is dark green, right? So we want 1 2/3. 1 2/3.
All right.
So you can see here clearly. 2/3 is going to be the length of 2 reds, which would be 2 reds. Right, so let's put that together. So then 2/3, yes. So anything that's the length of this plus that will give you your whole. Not that. Look like we got it, right? It's the orange. Orange. Good. All right, so that's that. My question then to you is, why would you use Cuisenaire rods in mathematics?
To visualize the numbers,
Yeah, well, visualize what kind of numbers?
fractions.
Fractional numbers. Comparing fractions, right? Comparing fractions. You would use Cuisenaire rods to compare fractions and to determine the relative size of fractions. Okay, so I'm going to put this aside for the time being. I'm just going to move this to the side. Now I want you to take your pattern blocks. Pattern blocks. These are pattern blocks. Pattern blocks. We're still on page 92. I just made what they have there, right? But before we do that, let's talk about the relative size of the pattern blocks. See, the first one we used were Cuisenaire rods. Now these are pattern blocks. So this is considered our hole, right? This is our hole. The yellow hexagon. Yellow hexagon equal one hole. The red trapezoid is 1/2. Red trapezoid. The blue rhombus. And the green triangle. Okay, so we have, notice that you put those two together and it gives us one of that, right? So we can say that this is the whole. And then this then would be 1/2. Right? Notice that when we put these three together, we get the whole again. So then we call this yellow hexagon. This is going to be the red trapezoid. This is the blue rhombus. And this would be the green triangle. So the whole, it takes 2 red trapezoids to make the whole, so that's 1/2. It takes 3 blue rhombus to make the whole, so this is 1/3. And notice it takes 6 green triangles to make the whole. So that is 1/6. 1/6. Now, if that's the case, and I say, what is 1/2 plus 1/3? Look at this. What is 1/2 plus 1/3? Here is my 1/2. Here is my 1/3. What is 1/2 plus 1/3? Just by looking at it. That's 1/2 plus 1/3. Half plus 1/3.
Pac-Man.
Was that?
It's Pac-Man.
Pac-Man, okay. 1/2 plus 1/3. Is it equal to 1? Is it less than 1?
Is it 5/6?
Who said 5, 6?
Bruno.
How do you get that?
I don't know.
You don't know.
There's one empty spot where one triangle would
There's
go.
an empty spot where the 1, 6 goes, right? Right in here. So then you're saying, well, if it's missing 1, 6, then what's there got to be 5, 6? Do you agree? Or how many of these, look at this. It takes 3 of these to look like that one, right? And it takes 2 of these to look like that one. So 1, 2, 3, 4, 5, and the name is 6, 5, 6. 5, 6. So let's see what they have here. Use 2 red trapezoids and 1 blue rhombus to construct a shape similar to the one shown below. Let's actually do that. That. Now we're going to put this in here. Okay, that's your shape. Remember, we use a half, and a third. Question. Given that the shape is 1, they're putting all of this together and said, that's 1. That's your whole. What pattern blocks would you use to represent each of the following fractions? 1/4. What would be 1/4?
A triangle?
Well, let's see. Let's see. Look at this. Weren't these 2 together to make that shape? Well, notice those 2 is equal to this, right? So if I ask you then, let me just put it back. How many blues, that's how many blue rhombus will equal this shape?
4.
4. 4. So what would a quarter be?
A blue rhombus.
A blue rhombus. So we're going to write 1/4 blue rhombus. And what pattern block or blocks would you use to represent 1/2? We want 1/2. That's your whole. We want 1/2. So if you want 1/2, can't we use this for 1/2? Or that? Because we use half of that and half of that. So this would be 1/2. Do you agree?
Yeah.
You take a half, the red, and then you take half of the blue, and the half of the blue is the green. So a red trapezoid and a green triangle will give you 1/2. 1 red trapezoid plus 1 green. Next, an eighth. An eighth. Remember, this is your whole. This is your whole. That's your whole. Do you agree that we could exchange the 2 red for these? These 2 reds we can exchange for the 6 green triangles. And then the blue, we could exchange that for 2 green triangles. So we are saying that this and this are equivalent. Sorry. Is that it? What did it say? Yes, this is equivalent to this. Any questions why? Can you see why? And we want to know what is an eighth. Here you have 1, 2, 3, 4, 5, 6, 7, 8. That's the whole. So this is equivalent to 8 green triangles. So what is an eighth?
A green triangle.
1 green triangle. 1 green triangle. So we come to the bottom of the page. Find the same shape using 1 red trapezoid, 2 blue rhombuses, and 1 green triangle. Sorry, fill the same shape using 1 red trapezoid, 2 green rhombuses, and 1 green triangle. So let's pull it out. 1 red trapezoid, here it is. 2 blue rhombuses. And 1 green triangle. So this is what we're using. And the question is, what fraction is represented by the following? A blue rhombus. Okay, so they're saying that this is your whole. Fill the same shape using 1. What fraction is represented by each of the following? A blue rhombus. Okay. So they're asking you, this blue rhombus is what fraction? Let's see what we can do here. How many blue rhombuses are involved in this shape?
4.
4. 4. So therefore, a blue rhombus would be a 4th. A blue rhombus would be 4. Andrea, did you get that one? All right. Follow me here now, Andrea. Follow me here. Look here. You got to look up here. Here is where the action is, right? Remember how many, okay, let me actually just do it, put it this way. Can you see here, Andrea, I have 3 blue rhombuses? Don't you agree that I can exchange this for that? So if I do, how many blues do I have in all? 4, right? So then one of them is a 4th. You got to constantly do the kind of the trading, right? So you can see the equivalency. So then 1 blue rhombus is a 4th. Now, what about a red trapezoid?
I have a question.
Yes.
So you're using a hexagon as your whole?
No,
But
no. I'm using they told us, fill the same shape using one red trapezoid, two blue rhombuses, and one green triangle. In other words, they're telling you that's your hole.
Oh, okay.
All right, so I'm going to go back again. It's going to be one red trapezoid. Here it is. It's going to be two blue rhombuses, take two of them, and one green triangle. So that's what we're looking at. We're making shapes out of that. So they want to know, if we consider that our hole, let's take a red trapezoid. This same red trapezoid here. Remember, this is how these are, right? That's how those are. We want a red trapezoid. Well, red trapezoid will cover those two, right? We got this left. So then, those two are really equivalent to this. So far you have this. That's what we want to get a similar shape. So one red trapezoid, they want to know is how much?
2/3.
Well, let's see. We sure about that?
I got 3/8.
3/8. Okay, okay. Well, let's see. Let's see. You have this, plus you got that. One of these is what you're looking for, right? One of these is what fraction? Really, how did you get the 8?
I exchanged
Because you got
the
6 of
trapezoids
these,
for
right?
triangles.
You got 6 of these in here, right? Plus this 2. So you're basically saying that that shape we talked about is equivalent to 8 triangles. Now, how many triangles are in here? 3. 3 triangles in here. If you don't believe, look at it this way. 3 triangles. So really, with the red, you're saying the red is really 3 triangles. And the whole here is really 8 triangles. So the red is 3/8. What about one green triangle now? What fraction is one green triangle?
1/8.
1/8. 1/8. 1/8. Question, what questions do you have? Okay, so we're gonna do some mental manipulative mathematics, right? You can't do any hand calculations. Okay, so let's do 2. Question 1. 2/3. Oops, sorry. Let's say So you gave Mary 2/3 of a candy bar. If John also received 2/3 of a candy bar, how much candy bar do they have altogether? So before you work it out, I want to know what operation you're using. How many operations are there?
Addition.
What operation are you using? Addition? So let's try that.
Addition.
Okay. So Mary, right? That's Mary. John. Remember now, this is our whole candy bar. That's the whole candy bar, right? Otherwise, that would not be 2/3. Following, Andrea? Okay. Mary and John. You said you're using addition. We're going to add those two together and see how much of a whole candy bar it is going to be. So, John, Mary, that's what they have together. What answer is that?
1 1/3.
1 or 1/3. 1 or 1/3. Therefore, we can say two-thirds plus 2/3 equals 4/3 equals 1 1/3. I wrote it out in words. Now, what about if we say 2/3 multiplied by 2? Is that the same thing? Is that equal to 2/3 plus 2/3? Question. Is 2/3 multiplied by 2 equal to 2/3 plus 2/3?
Yes.
Notice we used the manipulatives and we got 1 1/3. Same thing. 2/3. 2/3 times 1. 2/3 times 1 together, it's 2/3 times 2. 2/3 one time, 2/3 two times together, that will give you 2/3 times 2. Repeated addition is multiplication. Okay, so let's try another. You gave Mary 2/3 of a candy bar. If John received one-sixth of the candy bar, how much candy bar do they have altogether? You're going to put them together, right? Just put the pieces together and let the pieces do the talking for you. Here is Mary with her 2/3. And here is John with his 1/6. How much do they have altogether?
5/6.
5/6. Remember now, if you can't see how we got 5/6, you gotta say something.
I can't see it.
You said you can or cannot?
Can't.
Okay. Remember, how many green does it take to make the whole? 6 of them, right? And how many greens are we missing?
One.
1. So which means we have 5.
All right, I see it.
Good. Wonderful. Okay, so that's an addition using the manipulatives. By the way, we're going to come to the computation eventually. Don't be too anxious to get to the computation, right? All right. All right, so let's say John has 3/4 of a candy bar. He gave Mary 2/3 of a candy bar. How much does John have left? So how can we model this problem? We have to start out with what?
3/4.
3/4. Start out with 3/4. So here, John has 3/4. Actually, that would be difficult for you to do right now because I haven't shown you how to get the fourths. So let me change this around. John has, sorry, I haven't. John has, let's say, 2/3. 2/3 of a candy bar. He gave Mary 1/2. How much does he have left? Sorry for that. We haven't shown you how to get quarters as yet. So here is your 2/3. Remember, this is your whole candy bar. So here's your 2/3. John has 2/3 of a candy bar. He's going to give Mary 1/2. So here is your 2. He's going to take this and cut it like that, right? And what is he going to be left with? What is he going to be left with?
1/6.
Right, he's going to be left with a green, right? When he cut it, he's left with that. So how much does John have left? He has 1/6. So then you can say 2/3 minus 1/2 equal 1/6. All right, so it's 8:15. I'm going to give you a break until 8:30. Until 8:30, get stretch a little bit. You know, it's a lot of mental thinking going on here. Take a break and come back at 8:30. Okay. Now, we are going in some deep waters now. Get ready. Okay. Don't let this boggle your mind. Right, Andrea? So, see these two? That's my hole. That's one hole. One hole. Don't you forget that. That's one hole. Now, if two yellow hexagons equals one hole, then one yellow hexagon is equal what fraction?
1/2.
Yes. Any questions on that? Okay. Then one red trapezoid is equal what fraction? Don't answer yet.
1/4.
Just think it out. Think it out.
1/4.
1/4. Guys, remember? See, they're the same. So yes, 1/4. One-fourth. Then one blue rhombus is equal to what?
1/6.
1/6. Then one green triangle
1/12.
Yes. Whenever you have two yellow hexagons as your whole, one yellow hexagon is a half, one red trapezoid is 1/4, one blue rhombus is 1/6, one green triangle is 1/12. So here's my question to you then. What is 2/3? What would 2/3 be?
4 blue rhombuses.
My whole, I want 2/3, meaning I have to split this into 3 equal parts and take 2 of them. So let's see how we can do that. This is my whole, I'm just representing it differently, right? Look what I do now. I put my whole in 3 different parts. What fraction is this? 1/3. What fraction is this? 1/3. What fraction is this? 1/3. So what would 2/3 be?
4 rhombuses.
4 rhombuses. That's right. So 2/3 will be 4 rhombuses. I'll put them right over here. Two-thirds. Two-thirds. What would 3/4 be?
3 trapezoids.
Yes. Three-fourths. So we have the whole. We have a half. We have a fourth. We have 1/6. We have 1/12. We have 2/3. We have 3/4. Now, no need, remember now, you have your book in front of you. You have your notes in front of you. There is no reason if when I give you the whole as 2 yellow hexagons, you should get this wrong. It's right there. So if I ask you, Andrea, you probably think I'm picking on you, right? If I ask you, what is 2/3? Right away, you know. 4 blue rhombuses. Okay. So now let's see if we can do some of this work that's given us in the book. Okay. I am going to go to page 102. Page 102. Hundred and two. You have page 102? Okay, we're gonna ask Emily Ann to read what it says on page 102 for us, please, Emily Ann.
Okay, so use the pattern box to solve the following problems. Write your answers in the simplest form, that is the number represented by the least number of blocks of the same color.
Great. So notice our whole, we have it up there. Notice our half, we have it there, a quarter. We have a 6, we have a 12. We have more than what they ask us. So here is the first question. Now, here is the thing. You came to this class knowing how to, at least you've worked with it before, to compute fractions. We're not computing fractions now. We are reasoning fractions using models. So the first question is, what is a half plus 3/12? So I want you to directly model the problem. If it says a half, pick up the fraction pattern block that is a half. If it says a 6, pick up the fraction that is a 6. So let's do that. It says a half plus 3/12. So let's actually, here is my half and 3/12. 1, 2, 3. Do you believe that that's a half plus 3/12? Look, it's right here. Half plus 3 of these. Well, we want to know what it's equal to.
Two-thirds.
Okay, so let's actually write this out.
Oh, wait, 3/4.
So, Brenna, what are we using here? You're going to say 1 hexagon, right? 1 hexagon plus 3 triangles will give us what?
So it'll be 15/12, right?
It will give you what?
15/12.
Oh,
Or
well, we're not computing. We're not computing. We're not computing. Remember, I said don't compute. Look at what you got here. Look at this. 3/6, right? Is that, 3/12
yeah,
plus a half. How many 12s are in here?
12.
No, no.
6.
6,
Yeah.
right? Do you agree 6?
Yeah.
So 1 hexagon plus 3 triangles will give us 6 plus 3, 9 twelfths. Do you agree? Do you agree?
Yeah.
But that is also equal to how many 12ths are in here?
3/4.
No, how many 12ths are in here?
Oh,
3.
3,
How many 12ths are here?
9.
3 and 3, 6, and
3,
3, 9.
6, 9.
So a hexagon plus 3 triangles will give us 9 12ths, but that is equal to 3 red, right? Trapezoids, which is 3/4. You think you can do that? Notice we didn't do any hand computation. We just using the pieces and putting them together.
If this was a question on like a quiz, how would you want us to write it?
Exactly how I just did there.
Just like that full paragraph,
That's
pretty
like I
much?
did, yeah. And if you want to do some drawings, that's all right too.
Okay.
Professor, could you bring the camera a little bit closer so I could see that
Oh,
better?
sure. Whatever, yes, anything that makes you feel comfortable, I will do. Is that any better?
Yes, thank you.
Okay, great. Let's try that again. A half, we identified a fraction that's a half, and we identified a fraction that is 3/12. And then we decide, well, what's equivalent to that? 6 triangles in there plus 3 gives us 9 triangles, and each triangle is a 12th, so that's 9/12. But that is also equal to 3 and 3, 6, and 3, 9, which is 3/4, or 3 red trapezoids. End of story. So that 1/2 plus 3/12 equals 3/4. We can just write the statement. No computation, just write the equation. Let's take the next one. 3/4 plus 1/2 plus 1/6. 3/4 plus 1/2 plus 1/6. So I'm gonna ask here, Jessica, Gloria. Jessica, I want to represent this fraction. Tell me
Okay.
what I should use.
I would do 3 rhombuses.
3 red. Okay, good. So got that, and we got that. Okay, what else?
1 hexagon.
Good. Got that. Let me put it right here. Yep, 1 of that.
And 1 rhombus.
1 rhombus, blue rock. Good. So once we put all of that together, we're good. All right, so let's try. Let's try. Remember now, we're trying to see how best we can come up with a fraction without physically without physically computing them. All right, so give me a strategy. We're trying to find out how much this is equal to. What's going to be your first move?
I would take 2 of the trapezoids and convert them to an hexagon.
Okay, you're doing a little game here. All right, so you put those 2 together. Now you know, got my hole there, right?
Mhm.
Good. So now this is what I have left. That's what I have left.
And I can see that that's 5, 6 because 1 6 is missing.
Is that 5, 6?
Yes.
Remember what your hole is now.
It's 1 and 5/6.
Remember, this can't be 5/6 because,
Oh, right.
aha, two
So
of
that would
them,
be
two of them. So the question is, well, you can say, what's the smallest piece we got here?
12ths.
At 12. So how many 12s do we have in here right now?
10.
3.
Oh, wait. 3, 4,
11.
5.
4.
How many 12s are in the red?
Oh, 3.
3. And how many 12s are in the blue?
How's it 3? I
Two.
thought it would be 5.
Why would it be 5?
It's
Look at
5
this.
altogether.
Yes, all together. But how many in the red?
3.
3. And how many in the blue? 2.
Two.
Oh, I got
So
what you're
together,
saying.
5. Okay?
Yeah.
Yeah.
Good. So then 5 what?
12ths.
So your answer is 1 and 5
5
12s.
12ths.
So then you can make the statement 3/4 plus 1/2 plus 1/6 equal 1 and 5 12s. You probably say, I've never known you can do fractions like this. Yes, you can. That's why you can become teachers. Now, I'm not telling you to teach this to the little kids. No, this is just for your own college level type of thinking. All right, next. 3/4 minus 2/3. Three-fourths minus 2/3. Okay, so we will ask, Abby, you take this one.
Oh, lovely. Can I do 3 red trapezoids
Very good, very good. Here's your 3 red trapezoids.
and then 3 blue rhombuses? Right?
You want
No.
2/3, 2/3. Here, remember now, there is a reason I did this. You gotta keep looking here. If you look anywhere else, you might get yourself into problems.
Doesn't that say 2/3 though? The 3 blue?
But that's
Am I
not
looking-
3.
That's 4 blue.
4. Oh, it's 4 blue. Sorry.
Hey, you gotta say what's there, okay? So
It's been a
then,
long day.
so
4 blue
then,
rhombuses.
so here's what we do with subtraction. You're actually cutting this out from this. Do you understand what I mean by subtraction? You
No.
want to take, subtraction is a taking away. In other
Oh,
words,
yeah.
you want to take this amount from this, right?
Yeah.
So let's take. So if you take away equivalence, that's what you got. You take that away. So now you got to take away this from that. So to do that, what are we going to do? We're going to do this and that. Move that. That's what we got, right? So now you're going to subtract this from that. What are you going to have left? That. Let's try it again. 3/4. This is 2/3. You want to subtract this much from that. You can take away this and this. Those are equivalent pieces. Take that away. Now you have to take away this from that. So to do
Oh,
that,
okay.
all right?
I see it.
So
Yeah.
to do that, we will just get a representation, right?
Mm-hmm.
So this is that. So we just take that away. So now notice you could take that away now, right? So you take
Yeah.
away these two, and what's left is, what answer is that?
1/12.
There you go, 1/12. So 3/4 minus 2/3 equal 1/12. You write your equation.
That one.
Okay, now let's do 5/6 minus 3/4. 5/6 minus 3/4. 5/6 minus 3/4. And I'm coming to Jessica on that one. 5/6 minus 3/4. What do we start with?
I would start with 5 blue rhombuses.
Yes. Now, class, if you want to make this hard, you could. If you want to make it easy, you could. There is a reason I have these here. It's for your benefit, okay? It's for your
Oh.
benefit. It's for your
Okay.
benefit. Remember I said that, look here, that's the reason we did that. And 3/4. There's a reason we did that. So you should have it written down someplace.
I do.
Use that as your reference, okay?
Uh-huh.
All right, so 5/6. Notice Jessica says she realized that 1/6 was 1 blue, so she's going to use 5 of them. Good. Well, let's get 5 of them. You know, 1, and 2, and 3, and 4, and 5. That's a 5/6. Now you can put it however you want. That's 5/6. Now we want to subtract what?
I did this funky. I did 2 trapezoids and 3 triangles.
Okay, so really, this is the equivalent shape that we want, the equivalent amount we're trying to take away, right?
Yes.
So then you're gonna you're gonna cancel these two, right?
Mm-hmm.
Good. So now we want to cut this out from that. To do so, we're going to see that? We're just trading, right? It's like you
Right.
got $1 and I give you 2 50-cent pieces, right?
Right.
Okay, so now this is what we have. But look, you actually could do this, right?
Right.
Right?
Yep.
So now you can take away that with that. What are you left with?
1 triangle. So
One
1/12.
triangle, which is what?
1/12.
1/12. Want to try that again?
I understand it. I just took me a minute to roundabout get there.
No, that's all right. That's okay. That's all right. This is new stuff. This is new stuff. All right. So I am going to leave you to do number 5, 2/3 plus 1/2. 2/3 plus 1/2. 2/3 plus 1/2. Make sure you know what is it you're using. 2/3 plus 1/2. Okay, so 2/3. Let's ask Brenna. Brenna, 2/3.
So 4 blue rhombuses.
Okay, so use 4 blue rhombuses and
1 hexagon.
1 yellow hexagon. Okay, good. So then we have our 3 and that. Okay, what else, Brenna? What are you gonna put together?
The 2 red
Good. Put
trapezoids.
2 red plus yellow hexagon to do what? To make
1.
1 whole. Good, so we're gonna do that. Got your 1 whole. And what's left?
1/4.
Are you sure?
It should be 1/6, right?
Brenna, look over here. Look over here. Look over here. Look over there. Look at this. What does it say?
1/4.
Don't doubt yourself, fam. All right, so put
Hold
the
on.
two-
Hold on. The 2/3.
Yeah.
It
Oh,
was-
okay.
Yeah.
Sorry.
We're off.
Yes. Yes, the 2/3. She meant this.
Yeah.
She actually said 4, and I think that
She
Right.
did.
she did. I'm sorry. Thank you. See, I have people here who want to keep me straight. I like that. Okay, so this is your 2/3 plus 1/2. Sorry. Good. So use 4. See, I wrote 4 blue and put something else. So thank you for the correction. Put the 4 blue plus the yellow hexagon. Put the 3 blue, right? Put the 3 blue and the yellow hexagon to make 1 whole. Agreed, Brenna?
Yep.
Okay, so we're gonna take this out, put this here. So that's your 1. And what fraction is this?
1/6.
1/6. So our answer then is 1 and 1/6. Good. Now we have number 6 to do. 3/4 plus 2/3 plus 1/6. 3/4 plus 2/3 plus 1/6. Okay, so we have our 3/4. I think I used up everybody already, so I'll do this one. So 3/4 plus 2/3 plus 1/6. So if you're going to put these in words, use 3 red trapezoids, 4 blue rhombuses, and 1 rhombus. Right? You're trying to put them together to see how many holes we can make. So right there, you got a hole. Here, you got another hole. Sorry, right there, you got a half. So you got a hole there. And then this is what you got left.
Could you do that a little slower, please?
I'm just going with what we have here. I'm not moving anything. That's what you start with. Just trying to see how many holes I can make. So I move this here and I'm moving this over here because this is what's going to give me a hole. That's why I did that. Yes? Next. So this is what I have here left. I know I got 1, but I want to know what fraction that is. It's not quite a whole. So whenever that happens, look for the smallest piece. What's the smallest piece we have here? A 12th, right?
Yeah.
How many triangles are in all of these together?
7.
So 2 in here, 2 in there, 3 in there, 3 and 2, 5 and 2, 7. 7/12, 1 and 7/12. One and 7/12. Okay, so equals 1 and 7/12. Let's finish this up. We have number 7, 1.5 plus 2/3. One and a half plus 2/3.
On the test or on the quiz that we would have coming up, would we be writing this out in words or in shapes? Or does it matter?
Both, yeah. The thing is, if you do words, at least that will give you some points because I will know that at least you started it out right. If you
Okay.
don't do any of that, I don't have any basis for giving you partial credit.
What
Okay.
about if we give you the shapes from the beginning and then the shapes to the end?
Yeah. What you can do
For
is
me,
that you-
honestly, for me, it's easy. Just put the shapes in the beginning and then just draw it again. For me,
yeah,
it's
but
easy
you
that
know,
way.
but the shapes have a name, so you can just give them the names.
And at the end, we give you the whole answer, like 1, 7.5. No,
Yeah,
7, 6.
Well, I mean, it really doesn't matter because hey, you have a reference point here too. So 1.5. How are we going to represent 1.5?
You could
2
do
holes and 2 holes and the
1
half and the half.
and a half, right? Agreed? And 2/3, what are we gonna do about 2/3?
The blue ones.
How many?
The
Or
Yeah.
Or yep. Now what's next?
So you see that 3 blue ones equals 1 yellow. And you would
wanna
cancel those out?
You wanna actually do that? You can do that. You could switch, so of course you could switch. You
It'd
can
be
go trade
two-
if you want.
That's not what I meant, but
But that's what you just said. You said three blue equal 1 yellow. I just did it.
It'd be 2 and 6.
I know, but wait.
So it will be 2.
Yeah,
1,
hold on, just before you go there.
Oh.
Danielle, you said that you said three blue equal 1 yellow, and so I just do the next change.
right. I thought that you were supposed to cancel out one of the
It's
yellow.
addition, it's not subtraction.
Oh, okay.
This is addition. See, addition. So now we have that, and we have that, plus that for our answer. 1 hole, 2 holes, and what? Andrea, you said it was
2 holes, 1 6.
2 and 1 6. 2 and 1
Yeah,
6.
2 and 1 6. I still trying to get it.
2 and 1 6.
So if I was writing this out, I would write 3 yellow hexagons plus 4 blue rhombuses equals 2 and 1 6, or would I have to write out the actual like?
Well, the
Numbers.
question is, how are you getting there? How are you getting there? For example, let me show you how I would write that out. I
Yeah.
would start with,
So let's say if the same thing that you see the hexagons there on the board. If you see that on paper, would that be okay? Like we put all the hexagons together and
right, you got to use words to explain what you're doing. Yes, you just can't give me the pattern blocks and expect that I would know what they are. You have to explain them.
okay.
All right, so use 3 yellow hexagons and 4 blue rhombuses for the answer. Right? We know right away that's the answer. We just need to now figure out what it is. Now, so then you did that. And you did that. And you say 2 hexagons equal 1 hole. And 1 hexagon and 3 rhombuses equal 1 hole. And the blue rhombus equal 1 6. In other words, what I'm saying, I am doing exactly what you have here. I'm just writing it out. Shouldn't be any different. So the answer is equal to 2 and 1 6. 1, 2, and 1 6. So that is number 7. Now we go to the last one, 8, 1 and 5 6. 1 and 5/12 minus 5/6. Now this one, Danielle, this one is subtraction.
Daniel, it's a turn.
Huh?
No, never mind.
1 and 5/12 minus 5/6. Andrea, your turn again. 1 and 5/12.
I will use one whole.
One whole is how many How
Uh,
many yellows?
2 yellows. 2 yellows
That's my whole, okay.
and 1, 2, 3, 4, 5. 6 greens.
What does it say? What does it say?
5, 12. So I'm sorry, 5 greens. Never mind. 5 greens.
5
Right.
what?
Greens.
Look over here. Look over here.
1,
Oh,
12.
5 green. You said 5 greens. Okay, that's
Yeah,
correct.
the little ones. Yeah.
You are
triangles.
correct. 5 of them. All right. I was wondering. So,
And then
okay. So that's that.
I will use 5 blue.
5, 6, 5 blue.
Yeah.
Okay. So the goal is to to cut this out of that, right?
Yes.
So let's put this in some kind of a order. So I'm kind of setting it up, right?
Yes.
So we're gonna subtract, right? We're gonna move these together. Those two subtract, right?
Yes.
Then let's see what else. Can I move this and this?
Yeah. I
This
get.
and that?
Yes. So
They
I get.
cancel each other, right?
Yes.
So this is my answer. Whatever that is my answer. I just gotta figure out what it is.
And how to write it down?
Oh,
Because it's half and then it's 1/12. So
but you have to express your answer by looking at the smallest piece. The smallest piece is what?
1/12.
And how many 1/12s in here?
9, 6,
You sure?
3, 6. Yes. 3 and 3, 6.
How many? 6 in here?
Yes.
And this one give you what?
7.
So what's your
So
answer?
7, 12.
That's your answer.
Ooh.
Equals 7/12. Yep, equals 7/12. Okay, we will stop here. I know that I have assaulted your brain tonight. Yes, Danielle?
Can I just read to you how I wrote it down, and if you, can you
Sure.
tell me?
Sure.
that's okay.
Let me write down what you say. Go ahead, Danielle.
Use 2 yellow hexagons
Use 2 yellow hexagons
and 5 green triangles
and 5 green triangles
and 5 blue rhombuses.
and subtract
Oh, yeah. And subtract 5 blue rhombuses. Okay.
5 blue rhombuses. Okay, so well, we can do the operation. Two and 5 green. Five blue. Okay, what next? What next?
Then cancel or eliminate 3 blue rhombuses and
Okay. Arrange the blue rhombuses to get 1/2 and 2 blue. So I'm gonna do right that. Right? You arrange it to get that, right?
Yeah.
And then you arrange the 5 triangles to get to arrange 5 triangles. So here are my 5 triangles. I arrange it to look like this, right? Look like
Right.
that.
So
Mhm. What
arrange
next?
5 triangles to look like 2 blue rhombuses.
Yes. To equal the 2 blue. Because all you're basically doing is writing what you actually say you're doing, you know? Now, you're writing what you actually did.
So you would accept that if we're just
Oh.
writing exactly what we did, that's the
Absolutely.
correct answer.
Absolutely.
Okay.
The only thing is, is like some people just give me the answer like that. And it's like, well, how did you arrive at it, Because you can arrive at this computationally. I don't want you to do that right now. We will do that eventually. Okay, so let's do that. So at this point now, you're going to say, take away the 3 rhombuses from 1 yellow, right? So move that aside. And the 4 green with 2 blue, right?
Yeah.
Move that aside. Then you say, I am left with 1 yellow plus 1 green. 1 yellow equals 6. What was it?
6
1
triangles.
yellow is
6 triangles.
6 12s, right? 6 triangles. So together equal 7 green triangles, which is 7 12s. We just wrote out in words what we actually did.
Thank you.
That's all for tonight. I will give you homework that is based on this. Now, also the homework on MyMathLab is essentially fractions. Some of this you may not be able to answer all the questions. So I'm going to keep that MyMathLab open up. It wouldn't be due this coming Thursday till the following Thursday, because there's some information in there that I haven't covered tonight.
I have a question.
Mhm.
So the quiz that is due tonight at 11:59, I already did it twice. But there was some things on there that we didn't learn, like an unmagic square.
Yeah, I had a question regarding that quiz too.
The unmagic square? Wasn't my intention to give you an unmagic square. I just probably looked at it, selected, and thought it was a magic square. But if that's the case, I'll probably just have to remove it.
Okay.
Yes, it wasn't my intention to give you an unmagic square.
Okay. All right. So in future cases, if we do find material that we haven't learned on the quiz, what do you suggest we do?
Look it up on the internet.
Okay, well, that's what I did.
Serious.
Okay,
But, you know, I mean, it wouldn't, if there are things that I believe that even looking it up on the internet, you might not be able to really comprehend, then, you know, I wouldn't expect you to learn that on your own. But it is not material that is way out of your league, right? At least you would have had some of the rudiments explained in class. Okay, so you have yourself a good week. Look forward to homework. I am going to correct the homework and send it back to you. It's out of 10 points, okay? Make sure you keep up.
Did we get an extra credit for do the magic square?
If you did it,
Yeah.
I know that was coming.
Well,
Alright.
I have a headache, to be honest. I like, oh, yeah, it was
All
hard.
right, you take
It was
care. Have a
hard.
good night. I'll see you next week, okay?
Okay, bye.
All right, bye-bye.
Professor,
Yes,
I had a question on the homework, just because I'm stuck on some of the things.
sure.
And to be honest, I was trying to get it done this weekend, but I just couldn't get the video. Because the video we only taped half the class. The first part of the class, I like completely am thrown off about when it came to the homework. I didn't know if
Is there a particular problem that you're?
yes. So for instance, well, I'm having trouble with the subtraction and the dividing for the base numbers.
Okay. Emily, I said that the My Math Lab is, you could begin it, but it will open for 2 weeks. Don't wait until the last minute. Start it. If there are problems on there that you can't do, it'll.
Yeah, but I thought it shuts off on us if we don't do it. And when
He
That
sets
we
the
only have-
time limit.
what?
I'm talking about.
He sets the time limit.
Yes. Oh, the time limit.
So it's not going to shut off in 1 week. It's going to shut off in 2 weeks.
Right.
So that's regarding this last quiz that you just put out though.
Correct.
So we have this upcoming week.
Correct. And you
still
have
do
this
it?
week and the following week.
Okay. But yeah, I just need help on that because I tried going to the math
All right,
tutor that
so-
UCC
So
offers.
here is what we
here's
said
confusing.
about, okay, so what is the concept of division when you're using bases? We're using division as repeated what?
Subtraction.
Good. So let's say you have 134 base 5 divided by 1/2 base 5. Right? So let's say you have that. So what we will do is 34 minus 1/2, right?
Yeah.
So that will give us a 2, that will give us a 2. So right now you've subtracted once, right? Then next, subtract 1/2 again. Right?
What if there was a problem where, let's say the subtraction was 34 minus 15. Sorry, not minus 15, like
You couldn't do that in base 5.
when you're subtracting, you have to take one away from to go to the other number. That's where I'm getting confused and lost
Oh.
on
Oh, okay. So
in
let's say,
particular.
yeah, let's say you have 3, 4 base 6, and you want to subtract 1, 5. Right?
Yeah.
Can you subtract 5 from 4?
No.
So you're gonna trade 1 from here, you're left with 2. What are you gonna add to that?
The one.
Nope.
That's where I'm stuck. I have no idea.
What base are you in?
6.
You're adding 6 to that to give you 10,
Got it. So it'd be okay.
right?
So then
So
that
let me-
just, okay.
Let me show you guys something that you probably have been doing all your life. You don't even know why you do it. Look at this. Let's say we have 32 minus 18, base 10, right? And you subtract 8 from 2,
No,
borrow 1. What are you going to add to that?
the 1 becomes
10.
12. Oh,
Yes, but here is the thing. You're adding a 1. The only reason this works is because anything you add to a number in base 10 will give you the number. But basically, you're adding 10 to that. Because it's base 10. So you add 10 to 2, you get what? 12. That's why it works. 8 from 12 is 4. And 1 from 2 is 1. Okay, so I think this is what you were talking about. The one
Yeah.
you borrow, you don't put it here and call it 14 because that is only in base 10.
mhm.
So if you have this situation, let's say you have 23 base 4, and we subtract in 1, let's say 21 base 4 is subtracting 1, 3 base 4, right?
Mhm.
And subtract 3 from 1, say borrow 1, and this becomes a what? The one you borrow is a what?
So it'd be 5.
Yeah, it becomes a 5. Now 3 from 5 is 2, and 1 from 1 is 0. So the answer is 1, remainder 2.
Okay.
Can I kind of branch on this question? So for example, there was a question on our quiz
Mhm.
like this. But it was with much larger numbers. So you're still wanting us to use this
What number was
repeated
that?
subtraction
Oh,
method?
which quiz? You mean
It
on
was-
the? Yes, I would just use subtraction. Yes.
But so you want me, so the question was 4,144 base 5 divided by 32 base 5. Do you know how much subtraction that would mean? Wouldn't that be a
Well,
lot?
But there are other ways you can do it.
Right, and I did find a different way to do it,
Yeah.
but I didn't learn it. I mean, I had to figure it out on the internet.
Well, that's what learning is all about.
It is,
Self-learning.
but it took me like hours and hours.
But didn't you feel good about it when you were done?
Yes, I had a parade, I
Good.
had a party, but even the tutors didn't know.
Look at that. Now you can
Yeah,
become a tutor.
the tutors aren't really good help. And I
Now
was gonna
you can
ask
become
you.
a tutor now after this class.
I don't
How's that?
want to be a tutor.
All right, so yeah,
Okay.
yeah. But I can tell you in a test situation, I wouldn't give you large numbers. I probably give you a larger number because you have like a week to do it.
Okay, and
And
when's our
it's-
next test?
Yeah, I'm not I'm not focused on tests.
Okay,
So, so this test that you just put out last week, we still have one more week to do it.
The quiz. So yeah, so
Okay.
when we're ready, we'll do the test.
Okay.
No, the quiz is due tonight.
And I'm
And
talking
the
about, yes.
No, but I think Abby is talking about the quiz. That
I'm
quiz
talking
from
about-
last week,
yeah.
yeah, that
That
quiz
is
from
due
last
tonight.
week is due tonight. And then the quiz, the fourth quiz will be due in 2 weeks
There you
because we
go.
still haven't
Thank you.
covered everything.
Thank you for the clarification, Andrew.
Thank you for the clarification. Professor, I got a couple more questions for you.
I'm here.
Perfect. When you're calculating the value for B, how do you do that?
All right, here's an example, right? We have, let's say we have 3, 2, 3B, 4 base 5 equal to let me see, 3. Right, so let's say we have that, right? Let's say we have that.
Okay,
We want to turn it into base 5, right?
yeah,
So here's what I'm gonna do. I'm just gonna divide by 5. 5 into 8, 5 ones, 5 and 3, 8, 5 into 36, 5 sevens, 35, the remainder is 1. And 5 into 17, 5 threes, 15, and remainder is 2. Then 5 into 7, 5 into 3 can't go, so that's my last remainder. Oops, what happened there? Hold on. 5 squared, 75, 5 2's 10, and 4 is 85, 89, 89. Right? 89. So what if I change this to base 5, it would look exactly like that. So I'm going to try that. Remember now, if you change 89 to base 5, just keep dividing by 5 and keep track of the remainder, right? So 5 into 89, 5 ones 5 and 3 8, 5 into 39, 5 sevens are 35, and remainder 4. So that's 4. Next, 5 into 17. 5 threes are 15, remainder 2. 2 goes there. Then 5 into 3, not possible. So that's my last remainder. So if we have 3b4 equal 324 base 5, then what is b? 2. Or look at this. You want to find out the value of your number. That's 4. That is b. That is 3. This is 5 to the 0. That is 5. And this is 25. This is 1. So 3 times 25 is 75. Plus 5 times b is 5b. Plus 4 times 1 is 4. And that must equal 89. This is your place value. So now 75 and 4 is 79. So 5b plus 79 equal 89. So you subtract 79 from both sides of the equation. 5b is equal 10. Divided by 5, divided by 5. B is equal to 2. We will do some more of these next week.
yeah. Do you have like an extra day or a day that you like talk to your students? Just because, I mean, if someone needs extra help, just because the tutors at QC, they're very positive, but they're not very helpful. And yeah,
Okay, what time you?
I just don't, I can work around your schedule. I just don't.
Are you available when? Tell me, when are you available?
Just not Tuesdays and Wednesdays, I'm in class at night.
I am available on Sunday at 1.
When, okay,
Is that good for you?
I'll do whatever you give me.
Whoever wants to join, join, right?
All right. Thank you.
All right, take care.
I appreciate it.
No problem.
If we want to join, we just come to this Zoom.
Same Zoom, yes.
Okay, good night.
Mhm.
Thank you.
Take care.
Will you
Thank
be,
you, good night.
can you post the recording of the class for tomorrow? So I can go over
Well-
the notes?
Yes, I will. I will.